Alright, so the biggest thing that I want you to see about these is the difference between continuous and discrete. So here we have the continuous graph, and they're related here. So you have two different examples. You've got a linear arithmetic and an exponential geometric, okay? So see how they're related? So this is our new notation here. This is a sequence, but this is the same, essentially the same equation, but with a linear equation. So if I were to graph this, you could do that graph by plugging this in your table function and plugging in 3x minus 2. And we'll start at 1. So when x is 1, y is 1. So 1, 1. And then when x is 2, y is 4. So 2, 4. And then when x is 3, y is 7. So 3, 1, 2, 3, 4, 5, 6, 7. And you can see that that's starting to take the shape of a straight line here. Okay? So this is continuous because when you graph this, you're graphing all those points on that line. So the domain is all real numbers, and in this case, the range is all real numbers. But if we're graphing a discrete sequence here with a sub n equals 3 and minus 2, you're still going to plot the same points. So that was 1, 1, and it looks like 2, 4, I think. Yep, and then 3, 7. But you don't draw the line. And now your domain changes to all the natural numbers, okay? So that means like 1, 2, 3, 4, 5. We're not counting the values in between because we're just plotting the points. And your range changes to whatever your outputs are. So we have 1, 4, 7, forever to infinity. Okay? So let's do that with a geometric function now. So here we have a continuous graph we're going to graph. So I'll go and plug it in my table function. So I'll do 3 parentheses 2, and then I'll raise it to the x minus 1. And we'll start at 1. So at 1 we get 3, 2, 3. At 2 we get 6, 1, 2, 3, 4, 5, 6. At 3 we get 12, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you can see that you're starting to get that little exponential curve there. I'll go one more this way, so 0, 3 over 2. So that's about like right here. Okay, and so you would graph this and connect these dots here. Okay, so the domain, all the values of x that I can plug in is all real numbers. The range is all values of y that are greater than 0 because there's going to be that horizontal asymptote right here where this approaches here. But this is continuous because it makes sense to take on the values in between the points we plot. But with this one, this is a sequence. So you're going to plot the same points that you had. So that was 1, 3, and then that was 2, what is this? Here, and then 3 up here at 12. But we do not connect the dots. So now our range changes to all the natural numbers. So all natural numbers. But the range is going to be whatever the output is. So like look at your table here. It's going to be 3, 6, 12 from wherever you start. Okay, so 3, 6, 12, and then it'd be 24, etc. You can see that on here to infinity. Okay, and this is an example of a discrete function or a discrete sequence. Okay, that is all. Hopefully you're starting to get a better understanding, and I'll see you in the next video.